Kia ora everybody, Mr. Bowman here. This is another video for 2.12 probability methods, and in this video we're looking at all of the achieved questions from that 2020 exam. All of these questions are from the Quick Maths website. Link in the description if you do want to check more of them out. But question 23. So Tia finds a result of a survey conducted on staff and students at the university. The survey asked various matters in relation to ownership of EV electric vehicles. 15% of the survey were staff and the rest were students. So that there means it would be 85% students. 90% of the staff and 43% of the students drove to university. Of the students who drove to university, 36% they said they would like to own an EV, while 60% of students said they would like. Okay, so let's figure out the question. There's a lot of random numbers here. So find the probability that a randomly chosen student was a staff member who drove to university. So the nice thing is we don't have to worry about this. This was to do with whether or not they want EV ownership. That's not part of the question. It's only if they were staff and if they drove to school. Or drove to university. So let's start with my probability tree. So I'm going to write staff up here, and I'm going to write students down here. So one of these people, they're going to meet one of these two criteria, right? They're either going to be a staff or a student. So the staff here, as we said, 0.15 and 0.85 was the student down there. Of the staff, so 90% of the staff drove. So we're going to split the So drove and not drove. We're going to split the staff into drove and not drove. We know 90% of the staff drove, so that there is going to be 0.9, which means the didn't drive staff is going to be 0.1. We're going to do the same split for students, so they either drove or didn't drive. And that split, it was 43% of them drove to university, so that's 0.43, which means the other 0.57 has got to be down here. So we've got our tree. Back to the question. It says staff member who drove to university. That's going to be this group up here, right? So it's a staff member and they drove. So what I need to do is I need to multiply the branches together to find that answer. So the probability that they were a staff member and they drove will be equal to 0.15 times 0.9. Plug that into your calculator, and I'm going to get 0.135. Okay, we are now on to question 24, and this carries on from question 23, and that's why I haven't gotten rid of my working. So the question says, find the probability that a randomly selected respondent from the survey, that they were a student who did not drive to go to the university and would like to own an EV, or would not like to own an EV. So linking it back to our tree, so we've got student, did not drive, so it's going to be something to do with this branch, and we're probably going to need to split this one off based on the would they want to own an EV or not. So this here could be EV, and this here could be EV dash, so they don't want to own an EV. So he says here, of the students who drove to university, which is this lot here, 36% of them said they wanted to do that. So that's not relevant for us because we're splitting it off from the did not drive to university. So we carry on reading. While 60% of the students who did not drive said they would like to own an EV. So would not drive here. So we know 60% of them, or 0.6, is going to be there, which means this branch here is going to be 0.4. So I guess we're into question number 24 now. Should I write that down sooner? So we've been asked for the probability that they were a student and they did not drive to university and they don't want to get an EV. So we're going to multiply all these branches together. So it's going to be 0.85 times 0.57 times 0.4. So we plug that into our calculator, and I got 0.1938. We are now on to question number 25. We've got a car manufacturer about EV cars, and they say 127 of them, 127 kilometers of one full battery. Jeff, an EV owner, recorded the distance of his car. He found out that it can be modeled by a normal distribution, so that's really nice to see. So that clarifies we've got to use our normal distribution skills. We've got a mean over here, and we've got a standard deviation over here. Nice, so that information is really easy to spot. Find the probability that Jeff's EV will travel between 150 and 165 kilometers. So let's start off by drawing my normal distribution curve, and I'm going to put my mean down the middle, and the question told me the mean that was 165. So we've got 165 over here. Standard deviation of 14, so that normally goes at the top right of my graph. So there's 14, and I now need to put in the upper and lower, so 150 to 165. So let's kind of go, let's go 150 here, and 165 is already the mean, so that works out well. So we're trying to find the difference, this kind of shaded area over here. So on my calculator, just a reminder, I'm going to be using my NCD mode. It's going to ask me for a lower, which is going to be 150 in our case. It's going to ask us for an upper, which is going to be 165. It's going to ask us for a mean, a standard deviation actually next, which is 14. And then finally the mean, which is also 165. So that means the probability that they are between 150 and 165, so that's meant to be an X there in the middle. When I plug that in my calculator, hopefully you're getting the same answer as me, but I got 0.3580, and that had a 4 decimal point rounding. So we're now on to question number 26, which does follow on from the EV stuff from Jeff before. So find the probability that Jeff's EV car will travel more than 172 kilometers. So basically the same approach. Let's draw the graph, and then we get all the calculated inputs on the graph. So we had the mean. We already said that was 165. We had the standard deviation. We know that's 14. We've been asked for 172 or more. So there's my shaded area. So again, we're going to be using NCD mode. My lower is going to be 172. My upper, this one's tricky. So we don't really have an upper, it's just or more. Just a reminder, when that happens is just shove in a whole bunch of 9s on your calculator. So let's do 6 9s here. And the standard deviation is unchanged of 14, and my mean is 165. So that means the probability that X, being the amount Jeff travels on one of the batteries, is being greater than 172. We're going to plug all of those into the NCD mode, and hopefully you're also getting 0.3085. And that there had a 4dp rounding to it. We are now on to question number 27, and this is actually one of the nicest achieved questions I've ever seen, but let's read it. So we've got a study, and they're looking between the links of EV ownership and installation of a home solar system. Makes sense, right? If you're maybe into this sort of EV car type stuff, I reckon you're maybe more likely to have the home solar system as well. They've done an online survey in 2018. Here's the results of the survey, and we've been asked what proportion of survey respondents owned an EV or a plug-in EV. So we're trying to find the probability of an EV or a plug-in EV. So this type of approach, because we've got all the data, we're just going to follow a simple F over T approach. Let's start off with the total. So generically it says we're finding the proportion of respondents. So how many respondents are there in total? And that's going to be the denominator of my fraction. And the grand total, we've got 2,000 people who filled out this survey in total. So it's going to be out of 2,000. The favorable outcome, that links to what the questions actually asked us. And in this case, it's the plug-in or a plug-in hybrid or the regular EV type car. And we can see the totals over here. So there's my EV and PHEV. So it's going to relate it to these two numbers here. So 275 EV owners, 145 plug-in hybrid EV vehicles. So we're going to add those together. So that's going to be my numerator. So it's going to be 275 plus 145 as my numerator. That's going to get me to, adding them together, 420 divided by 2,000. And I always convert them to decimals. So that here got me to 0.21. Final question. We now are on to question 28. We've got a similar survey done in Europe. We've got a whole table here. complete the table and use it to find the probability that the respondent was non-electric, but they had a home solar system. So we know for sure they've got a home solar system. So we know it's kind of like a conditional type question. So, let's get into that wording part of it shortly. So let's fill in the table. So I thought my first one here, that's the easiest one here. So if I go 1,200 minus these two, that's going to get me to this number here. And when I did that on my calculator, I had 879. I'm now going to do the same up here. So I know this one plus this one has to come to the 225 total. So using subtraction, 225 minus 162, that gets me to 63 over here. I can now kind of figure out this one here again. 271 minus these two here, that's 185. Again, 1,200 minus this one here is going to get me to the total of the no home solar system people, and that's 929. I can figure out this one here, can't I? Doing subtraction, that's 73. And then the final one here, 294. So I filled up my table. Now let's check out the wording of the question just to make sure we know what we're doing. We know it's probably going to be conditional. So find the probability that a randomly selected respondent whose vehicle was non-electric. So we know for sure that they have a non-electric vehicle, which is a little bit different to my first read. And we're trying to find out of these people who had the home solar system. So the non-electric vehicle people are these guys here. So these are the only numbers that we actually care about. So let's start off with my notation. So we're trying to find the probability they have, let's go HS for the home solar system, given they don't have an EV. So let's write non-EV. So same approach as the previous question. I'm going to use F over T. My total in this case is the 879. So I'm not going to use the whole 1,200 because not all 1,200 are non-EV owners. Only those 879 are. So that's my denominator, 879. Of these 879, how many of them had the home solar system? That was the 185 up the front there. So 185 out of the 897 or 879 had the home solar system. So converting that to a decimal division on my calculator, 0.2104, and that they had a 4 dp rounding. Hopefully you'll get the same when you put that into your calculator. So that wraps up all the achieved questions for that 2020 exam. Hopefully you found them useful. If you're not sure about any of these things and you want further resources, or maybe you want to know how the graphics calculator works, do let me know in the comments and I can try to reply with something that's helpful.